this session, we solved some problems in quadratic equations and theory of equations. Let us face the first question. Question number 1. Alpha and beta are the roots of x square minus 6x minus 2 is equal to 0 with alpha greater than beta. If an is alpha power n minus beta power n for all n greater than or equal to 1, then what is the value of a10 minus 2a8 by 3a9? That is he wants to have. There are 4 options. The option A is 1, option B is 2, option C is 3 and option D is 4. Let us face it. First of all, what are alpha beta? Alpha beta are the roots of x square minus 6x plus minus 2 is equal to 0 with minus 2 is equal to 0 with alpha greater than beta. Alpha greater than beta. Moreover, he has given us an is equal to alpha power n minus beta power n. For all n belongs to n, that is greater than or equal to 1. The value of a10 minus 2a8 minus 2a8 by 3a9, that is required here. Let us use the data. Alpha and beta are the roots of x square minus 6x minus 2 is equal to 0. Let us first make use of alpha. Alpha is a root of that, implies what should have? Alpha square minus 6 alpha minus 2 is equal to 0. Now, let me multiply this equation with the alpha power 8. What happens? Alpha power 10 minus 6 alpha power 9 minus 2 alpha power 8 is equal to 0. Here we require a10. What is a10? Alpha power 10 minus beta power 10. Therefore, we must have alpha power 10 before us. Justly because of that only, I could have multiplied this equation with alpha power 8. So that we have alpha power 10 minus 6 alpha power 9 minus 2 alpha power 8 is equal to 0. Exactly in the similar fashion, absolutely in a similar way, we will be able to have beta power 10 minus 6 beta power 9 minus 2 beta power 8 is equal to 0. How? Alpha is a root of this. Similarly, beta is a root of this. That is beta square minus 6 beta minus 2 is equal to 0. By multiplying it with beta power 8, we shall be having this. Let us now subtract this equation from this. Alpha power 10 minus beta power 10 minus 6 into alpha power 9 minus beta power 9 minus 2 into alpha power 8 minus beta power 8 is equal to 0. Now we make use of the given symbolism. What is alpha power n minus beta power n? It is given to be an, like that. So alpha power 10 minus beta power 10 can be replaced by similarly alpha power 9 minus beta power 9. What can it be? It is a9 minus 2 into alpha power 8 minus beta power 8. What is it? It is nothing but a8 is equal to 0. Let us send 6a9 to that side. a10 minus 2a8 is equal to 6a9. 6a9. Good. Now a10 minus 2a power 8 by a9 is equal to 6. Actually, we need to have a10 minus 2a8 by 3a power 9. So again, divide on both the sides by 3. We shall be having a10 minus 2a8 by 3a9 is equal to 6 by 3. That is 2. So the answer is 2. It is available in the second option, that is option B. Option B is the right answer. So in making an attack on the question, you have to understand the actual meaning of AN, that is alpha power n minus beta power n, and the requirement is A10, A8, A9. They must be before you. You must be having at your disposal. Justly to have them, we are multiplying this with alpha power 8, similarly with beta power 8 to have the requirement. So what is the right option? Option 2 is the right option. That is option B. Answer is 2. Let us look at the next question, that is question number 2. The range of the values of A for which all the roots of the equation a minus 1 into 1 plus x square whole square is equal to a plus 1 into 1 plus x square plus x power 4 are imaginary is. He has given us a lengthier equation and he wishes to have the roots of that equation to be imaginary. The options given here are option A, open interval minus infinity to minus 2, closed towards minus 2. Option B, open interval 2 to infinity. Option C, open interval minus 2 to 2. Option D, closed interval 2 to infinity. These are the options. Let us observe the given equation first of all. What is the given equation? It is a minus 1 into 1 plus x square whole square is equal to a plus 1 into 1 plus x square plus x power 4. 1 plus x square plus x power 4. In the right hand side, we have a special expression, namely x power 4 plus x square plus 1. This can be taken as 2x square plus 1 minus x square. This is just nothing but x square plus 1 whole square, and this is minus x square. This looks like a square minus b square, that is a plus b into a minus b. Therefore, we can write 1 plus x square plus x power 4 as x square plus 1 plus x into x square plus 1 minus x. I am replacing this by that product, a plus 1 into x square plus x plus 1 into x square minus x plus 1. Bringing all of these to one side, what shall we have? A plus 1 into x square plus x plus 1 into x square minus x plus 1 minus of a minus 1 into x square plus x plus 1 whole square is equal to 0. Here we can have x square plus x plus 1 as a common factor here. What are we left with? A plus 1 into x square minus x plus 1 minus of a minus 1 into x square plus x plus 1 is equal to 0. Is equal to 0. Good. X square plus x plus 1 into, come on, x squares. You gather x squares. Here it is a plus 1. Here it is minus of a minus 1, minus a plus 1. And then minus x, let me gather, minus x into, here it is a plus 1 and here it is a minus 1. Then constants, plus a plus 1 minus a plus 1 is equal to 0. Isn't it? Let me see once again. X squares, here it is a plus 1, it is minus of a minus 1, minus a plus 1. X's, it is minus x into a plus 1, here minus x into a minus 1, a plus 1 plus a minus 1. Isn't it? Minus x into a minus 1 is available here. And then constants, 1 into a plus 1 minus of 1 minus 1 into a minus 1 minus a plus 1 is equal to 0. What is going to happen? Here a will be cancelled, here 1 will be cancelled, here a will be cancelled. What is going to happen? X square plus x plus 1 into 1 plus 1, 2x square, a plus a minus 2ax, 1 plus 1 plus 2 is equal to 0. Is equal to 0. So that this equation can again be written as x square plus x plus 1 into x square minus ax plus 1 is equal to 0. From the last step, we see that this can be split into two equations. One is x square plus x plus 1 is equal to 0 and the other is x square minus ax plus 1 is equal to 0. We all know that the roots of this equation x square plus x plus 1 is equal to 0 are purely imaginary. You can recollect the roots of this are nothing but the complex cube roots of unity, that is omega and omega square. So they are absolutely complex numbers, that is not real, that is imaginary. So we need to have that both the roots of this equation, that is x square minus x plus 1 is equal to 0, must be complex numbers, that is imaginary. So what is the basic requirement now? We require x square minus ax plus 1 is equal to 0 must have imaginary roots. Must have imaginary roots. Okay, for this equation to have imaginary roots, what should happen? Discriminant must be less than 0. What is the discriminant here? B square minus 4ac must be less than 0. That is s plus 2 into a minus 2 must be less than 0, and thereby will be very easily tracing the domain of a to b, open interval minus 2 to 2. As a plus 2 into a minus 2 is less than 0, we must have a in the open interval minus 2 to 2. Well, in this answer, that part which plays the key position or the key role is this idea. You must be able to write x power 4 plus x square plus 1 as this product, which helps us a lot, of course, in pulling this out, x square plus x plus 1. And that quantity which is inside in this big brackets is again a quadratic form. So that to have all the roots imaginary, this equation, this part x square minus x plus 1 is equal to 0 part must also have imaginary roots, which requires this, and it is very easy to estimate the answer as a belongs to open interval minus 2 to 2. That is option C is the right option. Now we turn our head towards the next question, that is question number 3. A group of students decided to buy an alarm clock priced between Rs 170 and Rs 195. But at the last moment, 2 students backed out of the decision, so that the remaining students had to pay 1 rupee more than they had planned earlier. If the students paid equal shares, the price of the alarm clock is. A beautiful concept is involved here. We must be able to pull the information given in terms of a quadratic equation or expression. Let us do that. There are 4 options. The first option is 190 rupees, second option is 196, third option is 180, and the fourth option, that is option D, is 171 rupees. Let us face the question. What is the main question here? The price of the alarm clock is, let me suppose it to be some x. Let the price of the clock is equal to x. One more unknown is here. What is the number of students? We do not know. Let me assume. Let the number of students be n. Price of the clock is x. In the beginning, number of students is n. They would like to share the total cost. So what is the earlier plan? X by n. X by n. Later on, two of the students backed out of the decision. Therefore, only n minus 2 students are to share the total cost. Then x by n minus 2. If this is true, naturally the contribution of the individual increases than before. How does it increase? They had to pay 1 rupee more than they had planned earlier. According to the earlier plan, what is the contribution? X by n. And in the second condition, in the second situation, that is after 2 students backed up from the decision, plus 1. This is the situation given in the data. Let us now try. Therefore, x by n minus 2 minus x by n is equal to 1, or x into 1 by n minus 2 minus 1 by n is equal to 1. That is x into n minus of n minus 2 by n into n minus 2 is equal to 1. N and n will go away. This is 2x by n into n minus 2. Therefore, 2x is equal to n into n minus 2, or x is equal to n into n minus 2 by 2. That is, x is equal to n square minus 2n by 2. He has given a lot of information about it. That is about x, the price of the clock. What does he say? It lies between 170 and 195. That is 170 less than or equal to x less than or equal to 195. That is 170 less than or equal to n square minus 2n by 2 less than or equal to 195. You shall be having two quadratic inequalities. Two quadratic inequalities with one less than or equal to and the other one with greater than or equal to. You are supposed to produce them and then solve them. Of course, it is not impossible. You can do that, but it is a brisk procedure. Let us do something. Among the four options, which is the suitable option which gives us n, or the quadratic expression in terms of n, reducible to factors. As n is a natural number of students, so we must have roots of that quadratic equation in n, which is going to be obtained purely rational. That is, it must be reducible to factors, to linear factors. Let us have a check about the options. And it is very easy to identify that the option x is equal to 180 gives us here the suitable situation. That is, if x is equal to 180, then what is the equation? N square minus 2n is equal to 360, or n square minus 2n minus 360 is equal to 0. It can be factorized very simply. N minus 20 into n plus 18 is equal to 0. That is, n is equal to 20. It is quite easy to estimate. And the value 180 helps us to factorize this. Therefore, we notice that x is equal to 180. This is by the procedure, the method of verification among the given options. And it is easy to see that x equal to 180 is the most suitable option. If you do not want to go in this procedure, you are supposed to solve those inequalities. What are those inequalities? 170 less than or equal to n square minus 2n by 2 less than or equal to 195. You can do them and you can arrive at this, x is equal to 180. Therefore, option C, that is 180 rupees, is the suitable option for this question. Let us follow the next question, that is question number 4. Let A, B and C be real numbers such that A plus 2B plus C is equal to 4. Then the maximum value of AB plus BC plus CA is option A is 1, option B is 2, option C is 3 and option D is 4. Beautiful information has been given. There has been a relation between A, B and C. What is the relation? A plus 2B plus C is equal to 4. And what do you want to have? What do you want to calculate? What is needed for us? The maximum value of AB plus BC plus CA is needed. Let me call that requirement, that is AB plus BC plus CA, by some name X, say. So we need to calculate the maximum value of X. When can it be maximum? No, or rather, what is the maximum value of X? Let us proceed. Here, 3 variables are there. Let us try to lessen the number of variables so that the information will be feasible and flexible for us to make the decisions. It can be done by eliminating one of the 3 variables. Whatever variable you can do, I would like to eliminate A from this. A is equal to 4 minus 2B minus C. Now let us substitute this A in this one. What happens? Therefore, A means 4 minus 2B minus C into B plus BC plus C into A. What is A? 4 minus 2B minus C is equal to X. Let us multiply this. 4 into B, 4B minus 2B square minus BC plus BC plus 4C minus 2BC minus C square minus X is equal to 0. Minus BC and plus BC can be cancelled. Minus 2B square minus 2B square minus 2BC plus 4B minus 2B into C minus 2B, minus 2B into minus 2B, just a minute, C minus 2 itself, minus 2B into minus 2 is 4B, minus 2B into C is minus 2BC, they are verified. Next one, 4C minus C square minus X is equal to 0. That is 2B square plus 2B into C minus 2 plus C square minus 4C plus X is equal to 0. Now, it is given that A, B and C are all real numbers. Therefore, roots of this equation must be real. Let us consider this equation to be quadratic in B. Therefore, the roots of this equation are real. Therefore, discriminant of this equation must be non-negative. What should happen? B square, but B is real. But B is real. Therefore, discriminant of this must be greater than or equal to 0. What is the discriminant? 4 into C minus 2 whole square minus 4 into 2 into C square minus 4C plus X greater than or equal to 0. You can ignore 4. So that, which are you going to have? C minus 2 whole square, that is C square minus 4C plus 4 minus 2 into minus 2C square minus 2 into minus 4C plus 8C minus 2 into X minus 2X greater than or equal to 0. C square minus 2C square is minus C square minus 4C plus 8C plus 4C plus 4 minus 2X greater than or equal to 0. That is C square minus 4C plus 2X minus 4 less than or equal to 0. Less than or equal to 0. Therefore, here we have C also real. It has been roots of this quadratic C square minus 4C plus etc. must also be non-negative. Must also be greater than or equal to 0. If you can apply, you can easily recognize that X less than or equal to 4. So, what is the maximum value of X here? At most 4. It can never exceed 4. X less than or equal to 4. So the maximum value of x is 4. What is x actually? AB plus BC plus CA is supposed to be x. Therefore, the maximum value of x here is 4. Option D, the fourth option, answer is also 4, is the right option. Let us now look at the next question, that is question number 5. In this question, if alpha and beta are the roots of the equation x square minus x plus 1 is equal to 0, then alpha power 2009 plus beta power 2009 is equal to. Option A is 1, option B 2, option C minus 1, option D minus 2. Yes, what is the given equation? X square minus x plus 1 is equal to 0. For this problem, it is essential for us to recollect one particular thing. We all know that roots of the equation x cube minus 1 is equal to 0 are called cube roots of unity. This can be taken as x minus 1 into x square plus x plus 1 is equal to 0. From this, we have x is equal to 1. From this, we have x is equal to omega comma omega square, where omega is equal to minus 1 plus r minus I root 3 by 2. And omega square is equal to minus 1 minus I root 3 by 2. We remember that these two are the complex cube roots of unity, famous omega and omega square. Not only that, we recall omega cube is equal to 1 and omega plus omega square is equal to minus 1. The reason being, product of the roots is 1 and the sum of the roots is minus 1. That is, omega plus omega square is minus 1. Why is it necessary for us to recollect this equation? Roots of this x square plus x plus 1 is equal to 0 are omega and omega square, and roots of this equation minus omega and minus omega square. Yes, but from data the roots are alpha and beta. Therefore, let alpha is equal to minus beta and minus omega and beta is equal to minus omega square. By the way, what is the question? Alpha power 2009 plus beta power 2009. This is equal to alpha power 2007 into alpha square plus beta power 2007 into beta square. What is alpha? Minus omega power 2007 into minus omega square plus minus omega square power 2007 into minus omega square whole square. What is the reason for me to split this 2009 as 2007 and 2? Because 2007 is a multiple of 3. Omega cube is 1, omega power 6 is 1, omega power 9 is 1, omega power 3n is 1. If the exponent of omega is a multiple of 3, then we believe and we recollect that it is 1. Therefore, this can be minus omega power 2007 into minus omega whole square is omega square plus minus omega square whole power 2007 is minus omega power 2007 into 2 into minus omega square whole square. Omega power 2007 is 1 because it is a multiple of 3, so this becomes minus omega square. Omega power 2007 is again 1, so it is minus omega. This is 1 minus 1 into minus omega square whole square is omega power 4. Omega power 4 is nothing but omega. It is nothing but minus of omega plus omega square. But from our knowledge, what is omega plus omega square? It is minus 1. Hence the answer is minus of omega plus omega square. It is minus of 1. It is nothing but 1. And among the given options, the first option, that is option A, is correct. Therefore, the answer is 1. Why is it possible to gain the answer immediately It is just because of our knowledge about the roots of this equation as minus omega and minus omega square. Moreover, it is very essential to recollect the formula of the nature of omega also. Omega cube is 1, omega power 6 is 1, omega power any multiple of 3 is again 1. And moreover, here we have got omega power 4. What is omega power 4? Omega cube into omega, that is nothing but omega. Like that, we'll be able to have the answer, and the answer is 1, that is the first option. A is correct. Now it is our turn to look towards the next question, that is the question number 6. In this question, alpha and beta are the roots of the equation ax square plus bx plus c is equal to 0, and gamma delta are the roots of the equation px square plus qx plus r is equal to 0. Capital D1 and D2 be the respective discriminants of these two equations. If alpha, beta, gamma and delta are in AP, then capital D1 is to capital D2 is equal to how much? The ratio of D1 and D2, the ratio of the discriminants he is asking us. Of course, another additional information has been given in brackets. Alpha, beta, gamma, delta, A, B, C, P, Q are all real numbers. Let us make use of them. The first thing from data is alpha, beta are the roots of ax square plus bx plus c is equal to 0. And gamma delta are the roots of px square plus qx plus r is equal to 0. Px square plus qx plus r is equal to 0. And d1 and d2 be the respective discriminants of these equations. Of course, from this you can write directly d1 is equal to b square minus 4ac, and from this d2 is equal to q square minus 4rp, rather 4pr. Let them be like that. One more important information it has been given in this problem is alpha, beta, gamma and delta are in AP. They are in an arithmetic progression. That is, let beta is equal to alpha plus d, gamma is equal to alpha plus 2d, delta is equal to alpha plus 3d, where d is the difference in the AP. As he has given that alpha, beta, gamma, delta are in AP, we can suppose them as alpha, alpha plus d, alpha plus 2d, alpha plus 3d. Well, observe alpha and beta. What is the difference of alpha and beta? D. What is the difference of gamma and delta? D. Why? Because this is alpha plus 2d and this is alpha plus 3d, hence the difference is d. Therefore, what can we observe? Mod alpha minus beta is of course d. But from our fundamental knowledge of quadratic equations or expressions, we know that the difference of the roots is nothing but square root of discriminant by mod a. And similarly, difference of the roots gamma and delta is again d. This is root d2 by mod p. Mod p. Right? From this, what can you see? Mod alpha minus beta whole square is equal to d square is equal to root of d1 by mod a whole square. That is, from this, d1 by a square is equal to small d square. d2 by p square is equal to also mod d square. Again, these two can now be equated because each of them is equal to d square. Therefore, d1 by a square is equal to d2 by p square. From this, we can get the required, that is d1 by d2 is equal to a square by p square. d1 by d2 is equal to a square by p square. That is, d1 is to d2 is nothing but a square is to p square. Which is the right option? Option A is the right option, as it has been given in the right option A as a square is to p square. Let us see the next question, that is question number 7. In this question, he has given a function, or rather a quadratic expression f of x equal to bx square plus cx plus d with a property f of x plus 1 minus f of x equal to 8x plus 3. The actual question is the value of b and c for which the identity f of x plus 1 minus f of x is equal to 8x plus 3 is satisfied, where f of x is equal to bx square plus cx plus d are: first option b is equal to 2, c is equal to 1. Second option b is 4 and c is minus 1. Third option b is minus 1 and c is 4. Fourth option b is minus 1 and c is 1. Let us approach the question. What is f of x actually given? F of x is equal to bx square plus cx plus d. Moreover, what is the property given? F of x plus 1 minus f of x is equal to 8x plus 3. 8x plus 3. There are 4 options given: b is equal to 2, c is equal to 1, b is equal to 4, c, etc., etc., etc. How to notice them? How to produce them? A very simple calculation. As it is an identity, you can replace x by any real number if you want. I like to take x is equal to minus 1 in the beginning. Why is it necessary? Justly to make this 0. Let me see what is going to happen. X is equal to minus 1 implies f of 0 minus f of minus 1 is equal to 8 into minus 1 is minus 8 plus 3. What is f of 0? It is d. What is f of minus 1? It is b minus c plus d is equal to minus 5. Is equal to minus 5. From this, d and d can be cancelled. Minus of b minus c is equal to minus 5. It means that b minus c is equal to 5. Let us first have a check about all the options. What is the first option? 2, 1. 2 minus 1 is equal to 5. 4ish. First option is wrong. Second option, 4 minus 1. 4 minus of minus 1 is 5. Yes, correct. There is a possibility for the option B for being correct. Let us see about option C. Minus 1, 4. Minus 1 minus 4 is not 5. Option C is wrong. Last option, minus 1, 1. Minus 1 minus 1 is not 5. So option D is also wrong. So by proceeding in a verification methodology, we notice that option B is the only right option that satisfies this condition, that is B is equal to 4 and C is equal to minus 1 by verification. By verification. That is what is the right option. Option B is the right option. If at all you do not get that idea, there is another procedure. We have taken x equal to minus 1, and in the second step you take x is equal to 0. What happens? F of 1 minus f of 0 is equal to 8 ones are 8 plus 3. What is f of 1? B plus c plus d. What is f of 0? D is equal to 11. Therefore, b plus c is equal to 11, and there we have got b minus c is equal to 5. Adding these two, you have 2b is equal to b plus c is equal to 11 and b minus c is equal to 5. You have 2b is equal to 16. F of 1, you have taken x equal to 0. F of 1 minus f of 0 is 8 into 0 plus 3 is 3. Is 3. Is 3. Yes. Now, if you add 2b is equal to 8, therefore b is equal to 4. If you take b is equal to 4 here, c is equal to minus 1. In either of the ways, you can make an attempt here to recognize that the answer is b is equal to 4 and c is equal to minus 1. That is the right option is option B.